This is an example of a free body diagram in Newton number 2. We will take a situation where we have a mass on a string. So let's say that we had a 2 kilogram mass and that it's held up in the air from the end of a string, and that the string is then accelerated upwards at 2 meters per second Find the tension in the string. Recall that the weight of mass m is given by m times g, where g is the acceleration of gravity and m is the mass in kilograms. And we'll use easy numbers here, taking g to be equal to 10 meters per second. So here's a free body diagram. There are two forces acting on the mass, the downward weight due to the attraction of the Earth, and a larger tension T acting upwards to give us a net force in the upward direction, because we know it's accelerating in the upward direction. So this is a consequence of Newton number 2. So here is the coordinate system that we'll be assuming: y direction vertically upward, x direction to the right. We won't be using the x direction in this analysis. We'll just be using the y direction. And so the Newton number 2 in the y direction is basically T minus W is equal to m times a sub y. A sub y is 2 meters per second. In this case, we know what the acceleration is, and we're finding the tension, the unknown in this equation. T minus mg, T is equal to m a sub y plus w. And so that's equal to, if we factor the big M out, since W is equal to mg, it's m times the quantity of the upward acceleration plus the acceleration due to gravity. It's 2 kilograms times 2 meters per second plus 10 meters per second. So that would be 2 times 12, which is 24 newtons. And therefore that is the tension in the string. You can see from this equation that if you increase the upward acceleration, the tension will be increased. A couple of questions for you. What is the tension in the string if the string is not accelerated? For example, let's say the string was moving up at 5 meters per second at constant acceleration. What would the tension in the string be in that case? Or if it was moving downward at 2 meters per second, or if it was just held stationary. Question number 2. What is the tension of the string as accelerated down at 2 meters per second? And the original problem posed was the string accelerating up at 2 meters per second. Question number 3. If the breaking strength of the string is 150 newtons, what is the maximum upward acceleration? Every string has a breaking strength. If you were to hang more than a certain amount of weight from it, it would break. But however the tension is created in the string, it can't hold more than 150 newtons. That implies, from this equation up above here, that there is a maximum upward acceleration. So I'd like you to find that.